Hey guys, I know that we just had a test on special right triangles, so I'm just here to ease your anxiety. So we are going to go back to solving right triangles where they're not 30, 45, and 60, but we're going to be using them in multiple quadrants. Not just a test on like reference angles or stuff that we've already done. I'm just going to expand upon the sine, cosine, and tangent and incorporate the lesson that we did on reference angles in the unit circle, and you'll see it's going to be awesome. So just to review, what are sine, cosine, and tangent used for? Well, these are what are called trig functions. And basically, in this class, sine, cosine, and tangent are typically used for right triangles, although the higher you go, there's higher levels of geometry where you do interact with acute triangles and obtuse triangles where you do use sine, cosine, and tangent. But the main thing that they're used for are solving right triangles. In particular, sine, cosine, and tangent are used to solve for the unknown sides of a right triangle. So if you're given an angle and one of the sides, you can use that information to solve for a second side of the right triangle. So, for instance, let's take a look at problem number 1. You've got a 53-degree angle, you've got a side length that's 11, and you've got x. So what information do we have in this diagram? Well, I'm going to look at the angle. In particular, I'm going to focus on 11 and x. So what information do I have if I look at the 53-degree angle? Well, 11 is my opposite side and x is my hypotenuse. What trig ratio lets me use an opposite side length and a hypotenuse? Soh kah toa. I've got an opposite and a hypotenuse, so that means I'm going to use the sine of 53 degrees to figure out x. In particular, the sine of 53 degrees is proportional to the diagram's 11 over x. Now remember, I can always make this sine of 53 degrees over 1 to make it an equivalent proportion. And then I can cross multiply. Sine of 53 degrees over 1 is equal to 11 over x, so I'm going to do 1 times 11 is equal to x times sine of 53 degrees. So x sine of 53 degrees is equal to 1 times 11. And then 1 times 11 is 11. So how do I get rid of that sine of 53 degrees? I'm going to divide both sides of the equation by sine of 53 degrees. And if I do, in the calculator, one thing I want to tell you guys, even though you guys don't have graphing calculators at home, I want you guys to either use your phone or go on Google and type in calculator. You pull up this tool right here. So remember, there are two angle measurements that I've taught you in this course. One of them is in radians and the other one is in degrees. Please make sure that you're in degrees. So if you click it, it'll go back to radians. Make sure that the degrees are black and the radians are gray to indicate that we are in the world of degrees. So remember, the calculation asked us to do 11 over sine of 53 degrees. So what you should do is make sure you're in radians. 11 divided by the sine of 53 degrees, and that's going to get me 13.773492 blah 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 blah. Round to the nearest 3 decimal places. So I look at 13.7734. Is the 4 going to round up or round down? I would round down. So 13.773 units. And the reason why I'm telling you guys to make sure that you're in degrees, not radians, because I guarantee I'll get a question going, okay, so let's say I do this in radians. 11 divided by the sine of 53 degrees. Okay. I would get 27.783 blah, 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 blah. So you would check your work by calculating the sine of 53 degrees. Remember that you can check your work by calculating the angle measurement. see if the sine of 53 degrees, the decimal matches up with 11 over x. So the sine of 53 degrees, according to the calculator, is 0.395925, blah, 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 blah. And remember that in the diagram, we wanted to solve for x, and x was 13.773. So check your work by calculating 11 divided by 13.773. Okay, so if I calculate 11 divided by 13.773, do I get the same exact decimal, 0.395? Nope, because I was in radians. Let me check. Sine of 53. There we go. You see why I check if I'm in radians or degrees, because the trig ratio does not match up. Okay? Anyway, so that is why I do what I do. So you can always check your work, but make sure you're in degrees. So let's take a look at 39 degrees, and let's solve for x. Well, according to our diagram, x is the adjacent side, and 26 is the hypotenuse. So what trig ratio am I going to use to solve for x? Well, the information given is that I should use the cosine ratio. In particular, sorry about that. In particular, the cosine of 39 degrees is proportional to x over 26, the adjacent over the hypotenuse. And remember that I can make this over 1. And the reason why in this unit I'm making it over 1 is because 1, I like to cross multiply, but 2, the cosine of 39 degrees isn't a special case right triangle where, you know, we have 30, 45, or 60. We don't know what the cosine of 39 degrees is. So it's okay to write this as cosine of 39 degrees over 1 is proportional to x over 26, where we cross multiply with each other. So we cross multiply with each other, getting us 1 times x. Oh, thank goodness, I don't have to do a lot of algebra. 1 times x is equal to 26 cosine of 39 degrees. And then if 1 times x is x, I don't have to do much. So I check my work. I do 26 times the cosine of 39 degrees. Degrees, awesome. And that's going to get me 20.2057, blah, 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 blah. But remember, I care about the first 3 decimal places, so that 205 rounds up to 0.206, because that 4th decimal place is 5 or more. So if it's 5 or more on the 4th decimal place, I'm going to round up. But what if you don't know if you got the correct answer or not? Well, you know that x is 20.206. So I do 20.206 divided by 26, whatever that decimal is, 0.777153, blah, 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 blah. And I'm going to compare that to the cosine of 39 degrees. Hopefully the decimals match up. Cosine of 39 degrees, not radians, should be 0.777, blah, 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 blah. Yes, so they match up, therefore x equals 20.206 is the correct length for x. All right, let's do 4 more of these. All right, so let's take a look at number 3. I've got 65 degrees, I've got x, and I've got 10. How do I solve for x? Well, let's take a look at 65 degrees. X is the opposite side. 10 is the adjacent side. That tells me SOHCAHTOA. Which one will let me use an opposite side and an adjacent side? The tangent. We haven't done this in a while, but basically the tangent of 65 degrees is proportional to opposite over adjacent, or x over 10. So the tangent of 65 degrees is proportional to x over 10. Then I could just make this ratio over 1. The tangent of 65 degrees over 1 is proportional to x over 10. I'm going to cross multiply and basically do 1 times x thank goodness, I don't have to do a lot of algebra, is equal to 10 times the tangent of 65 degrees. Then I get my calculator, because 1 times x is x. So all I need to do is just do 10 times the tangent of 65 degrees. I'm in degrees. Whew. And I should get 21.4450. Well, I'm going to look at that fourth decimal place, round up or round down. It's going to be 21.445. So, therefore, 21.445 is my x. I'm going to write it lightly so I don't have to keep jerking back and forth on the camera. And then I got 21.445 divided by 10. That's going to be my tangent ratio. So 21.445 divided by 10 is 2.1445. Well, fear not. Let's hope that the tangent of 65 degrees matches up with that ratio. .1445, blah, 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 blah. Very good. Okay. So then I'm going to give you two variables for number 4. Solve for x and y. So all I know is that there's a 40-degree angle. I'm given a side length 8, and I need to solve for not 1 but 2. This is business as usual. So it's just 2 steps. So first things first, let's say I want to solve for x first. I'm going to look at the 40-degree angle, right? X is the side that I want to solve, but 8 is the side that I know. X is the opposite side of angle 40 degrees. 8 is the hypotenuse. So what trig ratio am I going to use for x and 8? Sorry, what trig ratio am I going to use for 40 degrees? I'm going to use the sine ratio. So the reason why all the work is done in advance is because I made a huge error and I used cosine on this. But remember, sol katoa, I literally had to stop the video at this mark. So what is that, like 12 minutes? And go, oh no, I made a huge mistake. So the sine of 40 degrees over 1 is proportional to x over 8. I'm going to cross multiply and get 1 times x is equal to sine of 40 degrees. 8 times sine of 40 degrees. I just get my calculator now and I go 8 times the sine of 40 degrees. I'm in degrees. So then I look at the first 3 decimal places, 5.1423, blah, 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 blah. But if I'm counting the first 3 decimal places, 142 and the 3 makes me round down. So x is 5.142 approximately. Okay, now if I look at y, y is the adjacent side of 40 degrees and 8 is the hypotenuse. So I'm going to use sol katoa. That means I'm going to use the cosine of 40 degrees is proportional to y over 8. Now I'm going to cross multiply 1 times y and 8 times cosine of 40 degrees. So 1y is equal to 8 cosine of 40 degrees, and this is where I left off. So here we are. Now there's going to be some writing. So I got 8 cosine of 40 degrees. And I'm in degrees. Okay, cool. So I get 6.12835, blah, 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 blah. But all I care about is 128 in the 4th decimal place. Do I round up or round down? Well, that 4th decimal place is a 3, so I'm going to round down. So 6.128. So let me just update the diagram really quick. This is 6.128, and that x is 5.142. So there's a variety of ways to check your work. You could do Pythagorean theorem, 5.142 squared plus 6.128 squared is equal to 8 squared. So it should, I know that these are rounded decimals, so they should be pretty darn close to 6.128 squared plus 5.142 squared. My guess is it's going to be somewhere like 63.9999999, and 8 squared is going to be 64. So pretty darn close. The other way you can do is check your work by doing a trig ratio. So sine of 40 degrees should be equal to 5.142 over 8, or cosine of 40 degrees is 6.128 over 8. I like to use tangent to get that efficiency out of the way, so I'm going to do that. Let me get my calculator set up. I'm going to do 5.142 divided by 6.128, and I'm going to compare that with the tangent of 40 degrees, and hopefully we get the same decimal. So I don't really know what that decimal is, but it's about 0.839. But I'm going to check my work, and hopefully it's going to be 0.839 as well, the tangent of 40 degrees. There we go. That's how you know you got the correct answer. Okay. All right. Number 5 and 6, we're going to be solving for H and W. And number 6, you're going to be solving for U and T. Okay, so let's start with over here. So let's say I want to solve for H. So I'm going to look at 57 degrees. Well, I've got 15 is my opposite side, and I've got H is my adjacent side. Now, what trig ratio am I going to use? Well, the tangent, TOA, opposite over adjacent. So the tangent of 57 degrees is proportional to the opposite side over the adjacent side, 15 over H. So the tangent of 57 degrees over 1. Now I'm going to cross multiply. Oh man, I got to do a little bit of algebra. Oh man, I thought this was geometry class. So I'm going to cross multiply. Use my red since I can't find my green. So I'm going to cross multiply H times the tangent of 57 degrees is proportional to 1 times 15. So now I'm going to divide both sides of the equation by tangent of 57 degrees leaving me with H is approximately the 15 divided by the tangent of 57 degrees. So I'm going to get approximately 9.7411. That fourth decimal place 1 makes me want to round down. So 9.741. So I'm just going to update my triangle with H being 9.741. So 4. All right, now I'm going to solve for W. I'm going to put a little bit higher so I don't. Okay, and I don't want to take away Pythagorean theorem away from you. If you want to do 9.741 squared plus 15 squared is equal to W squared, go for it. So I'm going to look at the 57 degree angle. I like 15 and I like W. Looking at 57 degrees, what is the relationship between 15 and 57 degrees? Opposite, adjacent, or hypotenuse? It's the opposite side. And W compared to the 57-degree angle is the hypotenuse. What trig ratio am I going to use that has opposite and hypotenuse? So the sine ratio. The sine of 57 degrees is proportional to 15 over W. I can make the ratio over 1 because I'm going to cross multiply. It makes everything a little bit easier to deal with. So now I'm going to use 1 times 15 and W times the sine of 57 degrees. So 1 times 15 is 15. So W sine of 57 degrees. I'm going to divide both sides of the equation by the sine of 57 degrees. And I'm going to round to the nearest 3 decimal places. So W is approximately what? 15 divided by the sine of 57 degrees. So that'd be 17.8854. Well, I'm going to round down to 885 because that 4 does not isn't big enough for me to round up. So 17.885. So W is 17.885. I can check my work with Pythagorean theorem or a trig ratio, but I'm looking at the clock and I want to get through problem number 6. You can check with a variety of trig ratios, see if your decimals match up, or do Pythagorean theorem. Okay, number 6. Okay, so I've got 36 degrees. I've got a side length of 7. I want to solve for T and U. So let's say, I'm an alphabetical order kind of guy. Let's say I solve for U. Okay, so I'm going to look at my 36-degree angle. I like 7. 7's a whole number. I like 7. And U, that's the side length that I want to solve for. Not me, U. So I've got 7 and U. Well, U is my hypotenuse. That's pretty straightforward. But looking at the 36-degree angle, what is the relationship between 7 and 36? 7 is my adjacent side. Okay? Let me just get the other side out of the way. I don't want to make it disorganized again. So what trig ratio am I going to use if I look at my 36-degree angle and I have an adjacent side and a hypotenuse? I'm going to use the cosine ratio. So the cosine of 36 degrees is proportional to 7 over U. And remember, I can make this ratio over 1 and cross multiply. Now I've got U times the cosine of 36 degrees is equal to 7 times 1. So I've got U cosine of 36 degrees is equal to 7. And how do I solve for U? Well, I'm going to undo both sides by dividing both sides by cosine of 36 degrees and rounding to the nearest 3 decimal places. So that cancels out, that cancels out. And now I'm left with U is approximately what? 7 over the cosine of 36 degrees. And that is 8.6542. That 4th decimal place is a 4, so I'm going to round down to 8.652. Okay. Now, for the last part, we're going to solve for T. Once again, Since we've got u is 8.652, you could use Pythagorean theorem, 7 squared plus t squared equals 8.652 squared, and then solve for t. But I like trig ratios. Once again, I'm going to look at my 36-degree angle. And I like 7, big fan of 7. It's a whole number. I suppose you could use 8.652, but I like whole numbers. It makes my life so much easier. And I'm going to use t. What is the relationship between 36 and 7? Well, 7 is my adjacent side, and t is my opposite side. And a lot of people made this mistake on the test. Remember, what information do I have? Well, I've got an adjacent side and an opposite side. But remember, the expression goes SOHCAHTOA. So the opposite goes on top of the adjacent in order for us to be able to use the tangent ratio. So the tangent of 36 degrees is proportional to opposite over adjacent. So that'd be t over 7. And remember, we can make this ratio of tangent of 36 degrees over 1 is proportional to t over 7. Ah, I love it. I love it. 1 times t, I don't have to work. I love it when I don't have to work. 1t is proportional to 7 times the tangent of 36 degrees. So then I get my t, and I multiply 7 times the tangent of 36 degrees. And that gets me 5.0857. So that fourth decimal place is a 7, so if the last decimal place is 5 or higher, I round up. So that'd be 5.086. Okay. Hope this was a good refresher, and I'll see you guys on Thursday.